this is your assignment for next week. What I want you to do is, I want you to make a digital counter using your Arduino. Remember your most excellent eLego Super Arduino kit? You have LEDs in it. And I want you to make an LED counter that will count from 0 to 15. Now, how would that work? Well, how many LEDs will you need? You will need 4. All right, so how many pins will you have to connect those LEDs to on the Arduino? You'll have to connect to 4 pins. How many resistors will you need for this circuit? You will need 4, because each LED will need its own current limiting resistor. In your program, how many pin modes will you need? You'll need 4. Be sure and use variables, because you are going to have 4 LEDs. You'll have 4 pins you're using. You'll have to do 4 pin modes. Then what would you do? Well, I'll give you kind of a little hint. You'll do digital write, and then you'll use your pin, whatever your pin is, your first pin, and then you will write it low, right? You'll write the first one low, the second one low, the third one low, the fourth one low, and then you'll do that. Then you need to put a delay in, because if you don't, you won't be able to see it. So you'll need to write all of these low, and then you will need to have a delay. Then what you'll need to do is write the LEDs low, 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 high, and then put a delay, right? And then you will need to write them low, low, high, low, and then put a delay. And so what I want you to do is I want you to make a counter where it will be off, 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 wait a second, and then off, 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 on, and then wait a second, and then off, off, on, off, right? Like that. Off, off, on, off. So really, we could look at it like off, 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 what? On. Off, off, on, off, 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 on. I want you to cycle through these. Put the LEDs like this, wait a second, then put them like this, wait a second, then put them like this, wait a second, then put them like this, wait a second, and then cycle all the way down through all 15 numbers, and then if you do that in the void loop, it will just start over again. Okay guys, this is really exciting stuff to me, because even though I'm trying to do this quickly, it's really the essence of how an Arduino and every other digital electronic devices work. Everything is just a bunch of zeros and ones, and that's a bunch of switches that are on and off, and you are going to do this first binary assignment by writing the code and building the circuit to make a binary counter with the Arduino. Okay, guys, if you like this video, think about giving us a thumbs up.
Okay, so this is my first rendition of my code. It doesn't work because the logic that I implemented was that I had this like weird like carry on logic. I should have just like directly implemented like the adding logic for bits, but I didn't. So then terrible. But this is my second rendition of my code. So my second rendition of my code, I just directly implemented the adding logic. Later on in like my like vlog video or whatever, to show you like my actual thing, I will like explain more about each section of this code. But right now, it's just like I went back to the basics. I coded everything. I think my comments, okay, also the comments are like, they have typos in them. I realized I actually like fixed them in my blog, but yeah, so this is what I have. This one works. Really proud of it. Yeah, so this is the final version of my code. This is what I changed, and I made a function which I would talk more about later. So currently this is my code right now. This is what it looks like, as you probably saw before, and this is my old code, right? I try to like do some like carry logic where if because in bits there could only be zeros and ones, and I'm pretty sure in C++ you can add and subtract and whatnot in bits, but I wanted to like use my CS knowledge to implement it through ints, and then like kind of use this carry method that once it goes over 1, because bits there could only be 0 and 1s, right? Once it goes over, like here, right, if carry 2 equals to 2, which that's not supposed to happen for bits, because each carry is equivalent to 1 LED. Like 2 would be transferred over to like the next bit, if that makes sense. So this logic did not work, and then I was getting pretty frustrated, so then I decided to go back to the basics. So this is my current code right now. I added functions, and I actually implemented the but very basic bit algorithm for like how to add so that it carries over and it's like proper or whatnot. So then yeah, and then here I added functions to just like turn on. So basically, let's explain like the sections of code, right? So the first section is to establish like each pin that I'm going to be using. I'm using 13, 12, 8, 7, and 4. Also, while testing the LEDs out, I found it hard to know when I send the code in that it is like actually starting, if you know what I mean. Because if you guys know, once you start once you have your Arduino thing and then you send it to your Arduino and actually run the code, there's like this little blinking thing that happens with like the board itself, which causes like the LEDs to blink, and then it's like it blinks a couple times and then it actually starts the code. So I'm like, how do I know? Like, how do I know when it's actually starting the code, and how do I know when it's actually doing what I need it to do, right? So then I implemented a blue LED that would turn on once like my code actually officially like starts running, if that makes sense. Because the random erratic running of LED where it turns on and off, it only happens for like pin 13 for some reason. I don't really know the reason why, but maybe I could look into it later. So here, each pin, as you can see, I plugged it into like the side pins here. Like obviously it's connected to ground, and then 13 is like the first LED. Oh, also I color coordinated it. So red, like there's two, like there's the orange pin, and this pin is like the ground pin, right? Oh, the ground, yes. Orange connects to the ground, black connects to the blue LED. These are green, by the way. I know it looks kind of blue. Let me see if I could like make it look better. So as you can see, these are green, and then this one is the blue LED, right? And this first LED is representative. Okay, this is the full chart for like a 4-bit system, right? And here's all the possibilities counting from 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to 16. And these are like what the lights need to look like. So if it's shaded in, then it should be turned on, basically. So if you look here, the first LED, it's connected through like the schematic or whatever. I don't really know the terms, but this was like the red wires, and then this is like the green wires, the yellow wires, the blue wires, and then obviously the blue, as I said before, the black wires. That's how they're connected. So right now I just ran it, so that's why they're all turned on, because the final combination for like 16, for 15, sorry, but there's 16 in total because it's 0 to 15, so there's 16 combinations in total, but the final one is all turned on. As you can see, 1 1 1 1 equals to on. So all 4 of these, and it's like this, right? So this one here is like the first bit, this one the second, this one the third, fourth. This one tells us like if it's on or not. So here, let's go back to our code. Let's explain a little bit more about what's going on. So here, each bit here is like me trying to re-implement like the bit adding system, but like, I was really intentional about like actually adding it this time instead of like having this abstract adding system. So here's also my function to like just turn it on. I just tell the function what the bit is, what the pin is, and then it'll automatically turn, like check if the bit is 1. And if the bit is 1, then it'll turn the according pin to high. If the bit is off, which is 0, then it'll turn the according pin into low. I think my comments here in my code are pretty accurate. Okay, so if you scroll down here, obviously this establishes which pins I'm going to be using, and then the comments are in reference to like how I wired in my LEDs and whatnot. And then here I added the blue, and then I put it before my while loop to like run my stuff, to turn my blue LED on when the program starts. So as you can see, the program has ended, so then it's turned off because later on I turned the blue LED off when it is off. Oops, I think I forgot to comment this properly. Oopsies. Okay, let's go down to the while loop, right? So then I have my base case here. So the base case is basically when everything, like all the bits, right, which represent the LEDs, if all of them are turned on like at the same time, as you can see with the ands, then n equals true. N is the boolean I added here. So if n is false, then everything in the while loop will keep running. But then once the base case turns it off, so once everything is 1, once all the LEDs are turned on, basically, then I'll make n equals true. It will run the last bit of the code, and then it'll go back up, check that n is in fact true now, so then it won't continue running the while loop. Okay, so then this is my adding logic. Pretty self-explanatory. I just did the first one and then copy and paste it to the second and third, and then the fourth one doesn't need it because I don't have a 5th bit. But basically, if bit 1 becomes 2, then bit 1 goes back to 0, and it carries over to bit 1, if that makes sense. Like for example, here, let's say I'm like starting from the first one, right? So these are my bits. These are my, okay, don't look at the first column. I feel like that's like confusing, but like this equals to 0 in decimal, and this is like binary. These 4 are binary, so 0 0 0 0 in decimal is 0, 0 0 0 1 in decimal is 1, and then 0 0 1 0 in decimal, that equals to 2, right? So then so let's go back to 1, right? So what's 1 plus 1 in binary? So 1 plus 1, here, this is my bit 1, my variable. I add 1 here, that carries over. Like, for, if this is in accordance to my program, here, this is 1. 1 plus 1, I add 1 more, right? So this becomes 2. So then here in my program, if bit 1 equals 2, so if bit 1 is 2, then I would make bit 1 into 0, and I would make bit 2 into 1. So as you can see, bit 2 increases and bit 1 stays 0, if that makes sense. Yeah, and then I could have made this like into functions to like condense my code even more, but sometimes I need to consider like the readability of the code, which I think I don't really do. So I think it's just best to like leave it like this for like in the future, like make it like I don't really know, not that I'm gonna save like this code anyways, but yeah. And then here obviously I have like what I said with the functions, it turns on in accordance. So basically it's just after like all the adding logic, the adding logic literally is like every single time the while loop runs, at the very end, bit 1 1, which is the very smallest bit, is bit 1 is added each time. The bit adding logic trickles. Bro, I have so much typos. Oopsies. Bit 1 is adding each time, adding 1 each time. The bit adding logic trickles up to other bits, right? So literally the logic is just add 1 every single loop. That's like the differentiating thing. So then after I add 1, it goes through the logic. After it goes through the logic, it finalizes like what it finalizes and like goes to like the next one and the next one and next, like the next stage, right? So after that, it just checks like each individual like bit 1, bit 2, bit 3, bit 4 for like the variables I have up here, and then I just have it be linked to their according pins, and then like basically what I said before, if it's 1, turn it on. If it's 0, which is like the else, like if it's not 1 then it's 0, so if it's 0 then turn it off. So that's my logic. Okay, let's run this code. As everyone knows, you have to press this and then it's loading, so then it blinks a little bit, it's starting. So 0 1 oh yes, ta-da! Oh my god, yay! Also, let's talk about like some problems I had. Like I was really confused on like how to like turn like the LEDs on at the same time, but then like the problem was that I kept putting delays in between like each like turn on or whatever. So and even though there is a delay between like, because the code, it runs like linearly, right? So if one code comes first, if one code comes first, this will run. So like bit 1, if this is like on, right? Bit 1 is on, bit 2 is on, bit 3 is on, bit 4 is on, which means all 4 LEDs need to turn on. Then the first one will turn on first, the second one will turn off first, second, and then this is going to be turned on third, and then this is going to be fourth, right? I was like, how do I turn it on at the same time? But then I realized if I just don't put the delays in, then the electronics or whatever, it runs so fast that like you really can't tell like the difference, if that makes sense. But yeah, that was a problem. So like now the delay in between each like turn on, so it doesn't like just go like da-da-da-da-da, you know what I mean? I just put one delay at the very end, so it's like and this delay is 1 second because the delay is like in milliseconds, so 1000 milliseconds is 1 second. Okay, that's all I had to say. Goodbye.